Hello developers, welcome back. This is the first video of the series where we are going to build a web GPT, a chatbot that will have access to internet. So it will not be limited to LLM or the knowledge cutoff. It will also give you answer from the internet. So you can ask some recent events or something. So it will be very intelligent bot. So that's why we are calling it web GPT. This is the first video of that series where we are going to do the local setup of Qdrant vector database. And if you don't know about Qdrant, so basically this is an open source vector database and similarity search engine designed for handling high dimensional vectors for performance and massive scale AI application. That is what mentioned on the website. And it is open source, as you can see here on the right side. It has 20k plus stars, so it is very popular open source vector database. And in this video we are going to do setup of this database locally, so that without needing cloud infrastructure we can locally store and retrieve our vector database. And it also provides a cloud solution, and it is also very cheap. Like even in free plan you get 1 GB of cluster, and there are many things you get in the free plans. Let's get started with the local setup of this Qdrant. So for that you need the Docker, and if you don't have Docker you can go on this website or you can search Docker download and you can download it for your system. And once the Docker setup is done, or if you already have Docker, then well and good, you can open the terminal and run this command docker pull Qdrant. It will take 2 to 4 minutes and you will be good with the Qdrant client. And then you have to just run your Docker image that you just pulled. So in this way it will be running here. So let me stop it and start again so that you do not get confused. So once this pulling is done, just copy this command and run it here. And as you can see, it is running successfully. And to verify it, you can copy this URL and go in your browser. You will see this welcome page. So Qdrant local setup is done. That's it? No. Let's see some basic operations that Qdrant provide, so that we are familiar with the vector database if you don't know, and how some basic operations we can do in Qdrant, and also what we are going to build web GPT. It will also help you to understand that better. So we are going to deep down a little bit. So once this setup is done, let's start creating the collection in this vector database. And for that I have done this setup. You can run this code in your system either in a Python file by creating a virtual environment, or if you have the setup for Jupyter notebook, then you can also do like this in a particular shell. And if you don't know how to set up Jupyter notebook in your VS Code, you can just search Jupyter in extensions and it will install all the required extensions. And for this obviously Python extension is necessary. So these were the setup required for running the Jupyter locally. So first run this command pip install Qdrant client. And in my system it is already requirement satisfied. In your case it will install the Qdrant client. Let's clear out this output. And the first step, we will set up the client obviously. So here from the Qdrant client package we will import Qdrant client, and then we will set up the client by writing something like this: client equal to Qdrant client URL. This is the URL that is running here in our Docker container. Next is the creating collection. So this is how we create collections in Qdrant. From Qdrant client.models we are importing two things: distance and vector params. And from client.create collection, here you can give any collection name, and then vector config is equal to vector params, size is 4, distance is equal to distance.dot. And this dot distance, if I have to explain you here, they have mentioned something. So this collection will be using a dot product distance metric to compare vector. So they have some internal dot product distance metric they have developed. So that's what we are using here. And size is 4 because in each vector we are storing 4 elements, so that's why size is 4. So once you will run this command, let's execute it. I got error because this collection was already existing. So let's see the error. Collection already exists because I have already created it, but you will not get this error. Let's insert few elements in our collection, and I will not run it again because I will get error. I have already stored these points, and I will not get error. Actually these points will get stored again, but I don't want that to be even confusing, like we are storing just 6 points and why there are 12 points. So you can just run this command. So basically what we are doing here, from the Qdrant client.models, point struct is the model that we are using, and operation info is equal to client.upsert, and collection name wait is true, just to wait for this operation. Collection name is the collection where we want to insert, and these are the points. So we are just inserting 6 points here. In point struct we have few info like id, the complete vector array, payload. And if you want to see this vector, so if I have to explain you what we are going to build like vector, so in a real world scenario this vector will be a text, and from the text we will get the vector array. Here because in the Qdrant our purpose is just to work with vector, not with text, but if we are dealing with text or any real world project we have to deal with text. So let's say from a PDF we got some chunks, and from that chunks we converted that text chunk into vector, and then we will get this kind of vector. And to convert the text chunk into vector we need some OpenAI models help. So all those setups we will see in the upcoming videos. And these vectors, these are very small vector. I mean even for a one para of text there will be huge, like thousands of vectors in vector array, and this is just a simple example. And payload is basically helpful if you want to do some search or you want to filter out something, and it can be also helpful to identify your documents or the particular vector chunk or vector store. So here like we have stored city Berlin, and you can also store something like document version, or you can store the document author, published date, and based on that you can do filtering in the vector. So it do not need to go in all the vectors. You can have some filters, we will see later in this tutorial only. So once you will insert it, go to your browser, and here inside collections you can see we have test collection ready, status green, and we can see 6 points here. And click on this collection and you will see all the metadata of that, all the points, and the vector length 4 because we have inserted 4 elements in each vector. And if you will click on open graph, you can see the graph representation, all 6 vectors here. This one is the Berlin one, this one is Mumbai one, this one is New York one. So all 6 vectors are here. Now let's perform some basic search. So when you ask any query or anything from any LLM, first it takes your input or your prompt, and then it converts your query again into vector store, and then it performs the similarity search. So this will be a question or query that you will ask from LLM, and then that text will be converted into vectors, and that vectors are here inside query. So let's run it, and because we have limit 3, so we will get top 3 results. So top 3 basically it will perform similarity search and it will give us the top 3. Let's move further. So this is how metadata are useful. So here what we are doing, we are doing the query points, but this time we are applying the query filter and passing this must condition, field condition key is equal to city, and match is equal to match value London. So now it will do search only where city is London. Even though this time limit is 3, we got just 1 response because there was only 1 city, where city was London. So that is how metadata is helpful. So I hope you got some understanding around the vector database and the Qdrant setup. In the next series, we will start doing the basic groundwork for building the web GPT chatbot.